so good morning. Today we are working on equations with rational numbers. So you guys were really, actually, I was very impressed with how well you did with just solving regular multi-step equations. But now we are going to deal with fractions, which I know are the things that make you cringe super much. So I want you guys to get out of your head that fractions are these super complex thing that we don't know what to do with. Fractions are just dividing. So for example, if we look at example 1, this is just the number 7 divided by 10 plus the number 3 divided by 2, and which is equal to 3 divided by 5 times n plus 2. So I know that seems complex, but remember we have a way of getting rid of division, right? The opposite of division is multiplication. So if we want to get rid of fractions, we just multiply. And what you're going to find is we're going to multiply by the least common multiple. Now, if you think back, the least common multiple is the smallest number that two numbers multiply into, or in this case, since we have 3 fractions, that these 3 fractions multiply into. So we want to find the least common multiple first. So I'm going to just start. I know 10 goes 10, 20, 30, 40, 50, 60, etc., right? Well, 2 goes 2, 4, 6, 8, 10. And since 2 does end up equaling 10, that's pretty good. That's pretty good. That's what we want, right? And then 5, if I multiply by 5, I get 5 times 2, which is 10. So the smallest number that all of these multiply into is 10. So what I'm going to do is multiply by 10. So I'm going to multiply the whole thing by 10, which I know sounds crazy, but what it does is basically we're doing a major distributive property. So I'm multiplying 10 to 7/10, to 3/2, to 3/5, and to 2. So every single thing in here is going to be multiplied by 10. So what that looks like is I'm going to actually use the regular text box. With 10 on the outside of the parentheses. Move it right here. I'm going to use my drawing tool to show you that I'm multiplying 10 to 7, 10 to 3, 10 to 3/5, and 10 to 2. So if I break it down, then what that ends up looking like after I've done all the multiplication is 10, one fraction, 10 times 7 over 10 n plus 10 times 3 over 2 equals 10 times 3 over 5 n plus 10 times 2. So notice that on all of the fractions, I multiply the 10 to the numerator. That's because when we're multiplying, we multiply across, and you can pretend like 10 has 1 underneath it. For me, it's just easier instead of writing 10 over 1 to just start multiplying. So multiply the 10 to the numerator. So I want you to kind of take a second, digest this, make sure you got it written down. Remember, you're just multiplying. We're taking the original equation, and all I did is multiply 10 to the numerator, and in this case, because 2 is not a fraction, just 10 to 2. So I have 10, you could read, okay? So now what I'm going to do is I'm just going to start doing the math. Well, 10 times 7 is 70 over 10n plus 30 over 2 equals 30 over 5n plus 20. Okay, so I still have fractions, but you see these are all fractions that can actually be reduced. So I'm going to go ahead and reduce them now. So remember, this is division. Fractions just division. So 70 divided by 10 is 7. So I have 7n plus 30 divided by 2 is 15. 30 divided by 5 is 6. So 6n plus 20. And then now I have an equation that I can work with, right? This is something that we can deal with. So again, the key is to just get rid of the fractions so then you have whole numbers to work with. Obviously, you can work with whole numbers. It's just easier if you can just get rid of them. So, or with fractions, but it's easier if you can just get rid of them. So let's go ahead and solve this. So remember, I want to subtract 15 from both sides. And when I do, we'll show that. So remember, minus 15 minus 15. And when I subtract the 15, and then on the right, I don't want any letters, so I'm going to subtract the 6n. Remember, letters on the left, numbers on the right. All right, so I have some things that end up canceling out. Remember, I'm going to have the 15s cancel and the n's on the left, on the right cancel. So then 7n minus 6n is going to get me 1n. Should probably use the right tool. Or just n, right? And then 20 minus 15 is 5. So n equals 5. And then we're done. So it's pretty simple, right? And once you get rid of the fractions, such a fat line. But once you get rid of the fractions, it really becomes quite easy because oops. Anyways, because then you're dealing with just regular numbers. All right, in the second example, we're doing the same thing. We have 3/4 k minus 18 equals 1/4 k minus 4. This one's actually almost easier because if you check it out, they have the same denominator, right? So in this case, we'll still get rid of the fraction. Sometimes you can't, it's easy to just subtract the fractions if they have a common denominator because you don't have to do much. But I know you guys don't like fractions, so we're going to get rid of it. So again, least common multiple, where since they're the same number, the least common multiple is 4. So in this case, I'm just going to multiply by 4 to everything. So 4 over here. And then end the parentheses, because again, remember, this is like mega distributive property. So then I get 4 to the 3/4, 4 to the 18, 4 to 1/4, and 4 to negative 4. And then once I do all of that multiplication, I have 4 times 3 over 4k minus 4 times, actually, this isn't even a fraction, minus 4 times 18 equals 4 times 1 over 4k minus 4 times 4. Okay. 4 times 18. All right, so 4 times 3 is 12. So I'm going to have 12 over 4k. 4 times 18 is interesting. 4 times 18 72. Early in the morning for me. It's not going to do mental math today. And then 4 times 1 is just 4, so I'm going to have 4 over 4k. And I know I should, yeah, that's fine. And then minus 4 times 4, which is 16. Okay. I have some stuff that can be simplified, the 12 over 4 and the 4 over 4. 12 over 4 reduces to 3, because 12 divided by 4 is 3. So I have 3k minus 72 equals 4 divided by 4 is 1. And I'm not going to write 1k, I'm just going to write k minus 16. Okay. All right, so now I have letters, numbers. I need to get them isolated. So I'm going to add 72 to both sides, because remember, I don't want numbers on the left. And then I'm going to subtract k from both sides, because I only want letters on the right, variables on the right. I'm just moving these up so they're not taking up so much space. All right, and then things start to cancel, right? 72, k. 3k minus k is 2k. So 2k equals, and then negative 16 plus 72 is the same thing as 72 minus 16, which is 56. Okay. And then now we just have to do our last step, divide by 2. And when I divide by 2, k equals 28. 28 times 2 is 56. So our answer is k equals 28. I wanted to make this smaller. There's no reason why we need to square it. It's like super thick. All right, last example, we're talking about Danny. He walks from his house to the zoo at a constant rate. After walking 0.7 miles, 5 miles, he meets his brother Tony, and they continue walking together at the same rate. When they arrive at the zoo, Danny has walked 0.5 hours, and Tony has walked 0.2 hours. What is the rate in miles per hour that the brothers walked to the zoo? So we got to start by highlighting our important information. So I know that after walking 0.75 miles, Tony and him are at the same spot. So we're going to highlight that meets. And then I know they're walking together at the same rate, which means that they're both going the same speed. I also know that Danny has already walked a half hour, and Tony only ends up walking 0.2 hours. Eliana, can you get her juice? I'm trying to record. Your sister's going to get juice. All right. So then now I got to create my equation. So we're going to set this up. Our equation is going to be the distance covered by Danny plus the distance covered by Tony. Okay. And we know that they covered the same distance, which is why we can set them equal to each other. So for Danny's, this is kind of interesting, weird. And what we're going to do is Danny, I know, started out 0.75 miles. So I know he already walked 3/4 of a mile more than Tony did. So like I said, Danny has already walked 0.75 more than Tony. So what actually that's backwards. We're going to have Tony be equal to 0.75, and then Tony's rate is 0.2 hours. So 0.2, and we'll just put, plus 0.2h, because that kind of represents what Tony did. And then Danny's on the other side. Danny just walked for 0.5 miles per hour each time. All right, so our equation that we're looking at is 0.5h equals 0.75 plus 0.2h. Okay, so I have an equation now. Again, this is Danny. The reason why we're not adding the 0.75 to Danny is because even though Danny walked more, remember, think about this as like y equals mx plus b. This is an initial value. So Tony started farther away than Danny did. This, you could even think about the turtle. Remember that turtle thing that we did in Desmos? It's the same idea, right? Okay, so now I have something I can solve. And actually, decimals are easier to work with. So I'm not going to do any finding common multiples. I'm just going to subtract. Remember, decimals are just numbers too. So you don't need to poop your pants over this, okay? So the only thing, this is actually a pretty simple question. I just need to subtract the 0.2h over, because I don't have any constants on the left that need to be removed. Only the variables on the right. All right, and then I subtract. That gets out. So then 0.5 minus 0.2 is going to give me 0.3h. So 0.3h equals 0.75. Just divide by 0.3. And 0.75 divided by 0.3 is 2.5. So then I have that their rate is 2.5. So what that means is that they are walking 2.5 miles per hour. And I'm actually going to write that as a sentence because we got 2.5. But it's important to interpret what it means, remember. So they are walking at a rate of 2.5 miles per hour. And that's it. So hopefully now you have an idea of how to solve an equation for rational numbers.